Good afternoon, everybody, and welcome to Zahn Academy. Today's webinar is Trusana's Premium Denture System, 3Shape Design to Fabrication. Our presenters today are Daniel Alter, who is an MDT, MSc, CDT, Professor of Restorative Dentistry at the City University of New York, and the Executive Editor of IDT Magazine. Joining Dan is Kris Schermerhorn. Kris is a CDT and the owner of Northern Virginia Dental Laboratory. If you have any questions for either Dan or Kris, please send them to zondental@henryschein.com, and we will get those questions over to them and get the answer to you as quickly as possible. Thank you for joining us today and enjoy the presentation. Here's Daniel.
Fantastic, Fran. Thank you so much. And thank you, everyone, for joining us today for this webinar. It's really exciting times that we have. Digital dentures is by far one of the fastest growing trends in market. And it's an opportunity for multiple labs to, whether it's fixed or whether it's removable or full service, to get engaged with this great solution. And one of the things that I'm going to show you, and my friend Kris is going to talk about the Trusana, but I'll be showing you the actual design on 3Shape, how simplified it's become and how easy to get a repeatable and consistent result every single time. So again, when you first initiate the 3Shape in your order form, what I do is you first identify the artificial teeth and the library by which you're going to be choosing. Then you're going to be selecting the denture base, similar to what we have here. And then what I like to do, and this is really an option or a choice for you all, I like to break my complete arch into segments. So as you see here, the quadrant, the posterior quadrant, the 4 teeth is broken into a bridge. Then I have the 6 anteriors similar to here, and then the 4 anteriors. The reason for that being is not only is it for design purposes, but also for scalability. Specifically when it comes to 3D printing, the Trusana, it's easier to fit multiple segments into a build plate and therefore allow you to scale and produce more digital dentures in the process. Now, certainly you can also do a full arch, which some laboratories do that as well, and but you're limited to the geometric space within the build plate. So perhaps, depending on the printer, if you're using the Asiga, the smaller Asiga, you can probably get anywhere from 3 to 4 arches, where the larger Asiga, you can get more, perhaps 6 or 7 arches. But once you break it up into segmentation, like I'm going to be demonstrating here, you can really fulfill a lot more in a production. So that number goes up by approximately 50%, if not even greater. So it's really ultimately the choice of the laboratory as to how they want to break it up. As I said, again, you can do a full arch. You can also break up into quadrant as here. And many times, a lot of laboratories also like to break up in between the 2 centrals to create that proper illusion of individual teeth, which goes a long way. So then once you propose once you scan both the upper and the lower and also a bite block, you have this, what you see on your screen. Now, truth be told, oftentimes if you have a bite block, that's great, and certainly ones with a lot more information. But if you also, your dentist is able to scan the actual patient's denture, it makes it significantly easier. And that's also a process that makes it easier for the dentist because they're accustomed and they're used to working with teeth. And for us to be able to create that same centric occlusion and be able to get the aesthetics and what we want in the biological space is really important. Now, some patients don't want to bring that denture to their clinician, and I would suggest for you all to tell your clinicians, tell their patient, we don't care what it looks like, what it smells like, we just want to capture that geometry in order to be able to align the occlusal plane properly, as we're about to do now. So it's just a little tip that makes things a little bit easier. So here, for example, the first thing we need to do is the occlusal plane, and that's just a 3-point alignment. So what I do is I try to align along the complete arch, and what you see here is now that I'm going to bring out my alignment, and what I try to do is I make sure to get to where it's hovering over the entire arch, but also creating with the wax bite. I'm looking for where that muscle is, as well as any others. So then once we align that and it's in the right location, we can go ahead into next. And the next point is going to be the characteristic points. Characteristic points is we're doing the upper member or the maxilla right now. So the characteristic points are going to be tuberosities incisal papilla and canine. Now you notice here that the tuberosity has a number 1, a number 2, and what have you. The only criteria is really irrelevant as to which side you choose, the 1 and the 2. The only relevant is that whichever side you do choose, just stay standard with that. So for example, here I'm going to be utilizing tuberosity number 1 on the patient's right side. Then I'm going to be utilizing incisal papilla, tuberosity number 2 on the patient's left side. And then I have to cross again to the patient's right side to make sure that it corresponds with the canine point number 1 and canine point number 2. And those characteristics, along with your occlusal plane, is what's going to formulate the algorithm to give us the ideal mold that we can. So once you've established those, the next step is going to be to outline the border of your denture. Now, I go through this rather quickly because once you have the opportunity, you can always go into fast line edit mode, and I'll show you what I mean by that. It's just an easier, more efficient process to do so. Now, as I go around, one of the things you'll notice is that there is no post-dam in this case. Now, post-dams have shown that, the reason why we utilize post-dam, and oftentimes the purpose for it, is to create that suction or that, retention. And studies have shown that through that retention, with digital dentures, there's better retention than we have even with post-dam. And the reason being is post-dam are really created for the inefficiency of the denture, and particularly the polymerization stage. So, we're getting shrinkage rate of about 9 to 14% with traditional acrylic that we don't have with digital dentures. So for that deficiency of 9% to 14% is where we oftentimes need to include a post-dam in order to create greater suction and therefore greater retention. What we're finding now with digital is that, and studies are showing that the post-dam is not effective because now there's no shrinkage rate in any way, less than 1%. So therefore, the actual fit and the intimacy of that denture is significantly better. So, but if you absolutely want to have, and if your clinician wants to have the post-dam, we can still create that in the model stage, and we can score that for them just like we would with an analog model in the same exact fashion. So now I'm going to go ahead and I'm going to place my handles where I want to. If I want, I can just hover over one of them and go over into fast line edit mode, which then allows you to, in essence, draw where you want your borders to be for your denture all the way through. You want to make sure that you have the proper orientation, the proper mucosa all the way through, and you'll have another opportunity down the road should you need to change it when we're setting up the denture base. But I like to do this in this stage because then everything else becomes rather simple and seamless, which is now I'm going to go on to the next. So once we've established our boundaries, if you will, the next step is going to be to block out any kind of undercuts. And undesired undercuts, as you see here and here, could potentially create denture sore spots. So there's multiple ways of kind of correcting that. You can certainly correct it with this angulation. So by moving this to a 5 degree, you can see this will eliminate any of the undercuts. There's still a slight undercut here, but perhaps I would leave it as such. Now, to go back, just to show you another way, we can also use what's called out a blockout wax. Let's make it at 1%. So now we have our undercut here and potential sore spots. I'm going to hit it at 1%, and you're going to see it's going to block out the entire model at 1%. So now you have wax here blocking out any of the areas that are going to be suspect and that could potentially create denture sore spots. But we still have, similar to our conventional means, where we can add wax as we need. Perhaps in any areas where we want to alleviate more, we can take away. But the functionality is nonetheless still the same that you can achieve with your typical denture, conventional denture methodologies. So once we do that, we can then go on to the next, which is now going to give us the smile opportunities, or the smile composer. So you have a plethora of opportunities to select. We'll select the condylar. And the software, what it does is it provides you with what it thinks is the best carded tooth, if you will, or the library for this, depending on the characteristics, depending on the alignment. You can still nonetheless change it from delicate to universal, whatever it is, or vigorous, as well as the actual card sizes and dimensions through that, not only anteriorly, but also posteriorly. you can certainly do that. So here we have the condiform as well as the universal, which is what I'm going to keep, and we're going to go ahead and we're going to press apply. That's going to provide you with the entire library. Now, 3Shape has done a great job with really aligning these libraries in a great way so that you're able to fairly easily and seamlessly create a digital denture, and this is what we're showing you here. So the first thing I'm going to do is I'm going to bring back my wax bite, as you see here. Now I can move things as a group rather than individual, but then I'm going to focus on individual. So what I want to do is I want to then, once I align it where it needs to be, I'm going to go ahead and press my individual. And now I'm going to remove my wax bite, and I can start moving these as I see best fit. So realize that one of the first things as a default, it comes in as a symmetric design, as you see here. So what you'll be doing to one will happen to the other as well. So just be mindful of that if you want to make changes to just an individual tooth rather than both. You can certainly do that here, as you see, and it allows us to move these teeth to really set them up in the best or most ideal position possible. You still have, even though it's the mold, but you still have full functionality of changing the mold or reducing it or making it wider, making it narrower, or whatever you see fit, similar to what we do with an analog, but at this point in time, we're going to be doing it in a digital form. So it makes it significantly easier, where with an analog, if you tried putting in a tooth in an area that is perhaps too narrow, you'll have to take it to the to the lathe in order to be able to just narrow it slightly. So now you can do that very easily with just a shift of a mouse. So once I align that and I'm content with where the end results will be, I then go ahead and I move everything to the mirror plane. So this just for functionality and for processing, I'm going to move it over to the mirror and then the mesial, and you'll see a very slight movement, which is going to create our proper attachments once we get into that. And then when you get into the posterior, certainly we'll move it to the mesial again, but what you can notice here is if you had a lower member or a mandibular member with that library, it'll actually bring up that contact with antagonist, which is a nice feature. So you can really focus on the maxillary, get it to the setting that you really want, and then all you have to do is just bring the contact with the antagonist so that the mandibular arch or the mandibular teeth are going to move up to the maxillary teeth. So it makes designing these certainly efficient and very quick. Similarly, you have, again, you can see that you can remove any of the second molars should you wish to, or all the second molars, as well as bring it to antagonist. Then I'm going to do very much the same on the other side, just to ensure that everything is going to work seamlessly. As you see here, and it just aligns it and moves it to where we need it to with the mesial. So if there's any concern that you perhaps place the tooth in an area that is going to compromise the prosthetic, doing this will realign it in a great way. So once we've established that our teeth are where we need to be, I'm just going to reconfirm again that the individual centrals are out. It's over the arch, as you can see here, that allows us to really do a concise and correct setup rather quickly. So now the next stage is going to be multiple fold. So this is again with the 1% blockout. This is your second opportunity now to make or affect any changes should you wish to the denture base. So I'm just going to tighten this up slightly, get it to exactly where I want to, and that's all in good position. So then you have this window up here. Now you have multiple windows, obviously. So the first one is going to be if you wanted to draw the outline base here. The second one is if you wanted to draw a window, if you wanted to make a palatal kind of window, palatal seal, you can certainly do that. If there's any blocking out, you can do that as well here. Now with material settings, you know, you have a uniform base thickness of 1.5 millimeters, which, as you can imagine, in conventional means is very, very difficult to do. But you know, 1.5 millimeters is the very bare minimum. Now you can adjust it. My philosophy, in my opinion, is that 3Shape and other companies have spent a tremendous amount of resources and efforts to make sure to validate these systems. So unless it's absolutely necessary, I tend to stay always within the validated workflow so that it doesn't deviate and doesn't cause any unintended consequences. Then down here, you have the gingival effects. So the first one is very much the delicate that does not have a strong or robust root formation. Then you have natural, which is the one that I select. Then you also have the intense. And finally, you have a means of being able to create your denture base, but then save it to that. Now, my philosophy with this is that whatever it is, realize the CAD/CAM is just a tool. So what it is that your clients have grown to expect from your laboratory, the quality, if you will, should remain the same, if not even improved, by a more sophisticated tool such as CAD/CAM. So whichever way your dentists are accustomed to receiving work from you and the quality that you are producing for them should remain the same, if not better, due to this tool. So that's really a function, a differentiating function of your laboratory. So I'm going to choose the natural. Then down here is the drill compensation. If you were to decide, I know today we're talking about 3D printing, but if you decided to mill the denture base, just do make sure to click on the drill compensation so that it does accommodate for your smallest burr in your mill. I'm going to go ahead and I'm going to press next to show you that what it's going to propose as the denture, or the denture base rather, with these teeth, and then we'll still have the opportunity to make changes, and I'll show you the changes that I make along with it with the natural denture base. It's really a shortened learning curve because it's very akin to what is the traditional or the conventional design methodology, setting up teeth. So a experienced denture technician, or certainly somebody who's in the industry, can easily learn the steps as I'm showing you here in order to create or generate a digital denture similar to here. So the next step for us is going to be now to create what you will is the connections. Now the connector settings are down here, where once you hover over it, it'll tell you what specifically they are. Now the software again has that 80%, 95% lingual, as well as the center. And this is going to be for this segment, which I'm going to go ahead and press OK, and I'm going to use the default. I'll share with you, and you can see now the connections. So now it became a bridge. Now the next point is going to be now for the anterior. So I like to change it to 70 and 70, which is what I found to be a more correct pathway. And then we can go ahead and press next. So it's going to fill that in a great way. And then moving on to now the posterior as well, I'm going to select that too. So now you can see that all these segmentations are truly, connected, except between the posteriors and the anteriors. That allows us to make any kind of changes. Now, similarly here, you can still morph or change or add anything as you will, but I'm gonna, for the sake of time, I'm gonna move ahead to allow us to get into the denture base. Now, the denture base is something that is rather, I use the morphing tool, as you can see here with my control button. So I'm able to bring this on and off. And so I like to bring up my gingival slightly more, and being that this is going to be 3D printed, I can absolutely do that because I'm not concerned with necessarily the geometries, but I certainly want the root formation as well as the gingival to be in its right location. With this said, and Kris is going to go over it, if it's not ideal or perfect, and you can certainly add more post to allow you to really be able to stretch that in a great way. So once I do the sulcus, one other thing that I do is I like to do the root formations if need be. And again, I use my morphing tool with the control button, and then I just enhance it slightly. You want to be able to control that. So you would control your circle, which is going to be the amount of material you're going to be using. And really, again, this is dependent on the laboratory and your choice as to what it is that, how anatomical or how strong or intense you want it to be. So once I do that, obviously I can always go into adding, as you see here. So I'm going to add a little more root formation. I can certainly add in between the embrasures, and I can enhance slightly, as you will. And then one thing that I found that was really cool that you can see, I like to ghost when it comes to the rugae, ghost the denture ever so slightly, because now I can use the patient's rugae in order to create what they're accustomed to it or what they've grown to be used to. So I'm just literally tracing the patient's actual topography or oral environment, as you see here, to create a rugae that is comfortable for the patient because it's something that they know and that they can absolutely utilize. So then I enhance it slightly as need be, and then I would go over it and smooth to create that rugae that they're absolutely used to. So once we do that, that becomes something of where their tongue gravitates towards. It's something that they really are used to. Now I'm going to go ahead and I'm just going to smooth out the areas in this process. And then once we complete this, we're then going to go into the coupling mechanism. Now the coupling mechanism is the means by which the teeth are going to be coupled, and therefore it's considered coupling, to the denture base. So again, there's a 2 millimeter of a coupling depth, which means that the teeth are going to be recessed into the denture base at approximately 2 millimeter, as well as a 10-degree depth. So what that does is it provides you, the laboratory, with the ability when you're post-processing that it seats into one way and one way only, so that you don't have to worry about will you have to equilibrate or rebalance or anything like that. So again, each segment will have its own. So I'm going to go into from one to the next. And then once I've coupled that, the last step is going to be the pre-manufacturing. Now the pre-manufacturing is where the software now is going to generate or create not only the denture base, but the individual segmentation, as well as the coupling and so on and so forth. Now, if you were to mill out the denture teeth, do make sure to click on the drill compensation. But again, this is something that we're 3D printing is what we're discussing today. So I'm going to leave that as off. Now there's multiple opportunities. You can do a denture base, you can do with multi-layered kind of anatomical teeth, or PMMA rather. But certainly 3D printing has proven itself to be the most scalable and most efficient process in being able to produce digital dentures. Now, as you've seen, in about 15 to 20 minutes, a designer can design a denture, post-process, and once this is complete, I'm going to show you the STL files that it produces in a great manner. It also offers you a opportunity, and the workflow that I shared with you is to do the try-in as well as the definitive at the same time. So you can decide and select whether you want to send the clinician the try-in, which is monolithic all the way through, or if you want to do a definitive, which 8 out of 10 times I do favor the definitive, only because the libraries have become so equilibrated, for lack of better terms, that any kind of adjustment is no longer necessary, and therefore the patient 8 out of 10 times walks away with that denture, thereby saving the clinician another appointment time, saving the patient with the needing for the experience of having to come to the clinical settings again for another, and it's a win-win for the laboratory, the clinician, and the patients in a great way. And that now becomes your denture. This is ready. Once it finishes processing, this will be ready, and I'll go ahead and I'll show you how to open up the STL files. But this is where you have your artificial teeth, gingiva, and then obviously artificial teeth. Now, forgive me. So here you have, this is where the case is. I'm going to go ahead and I'm going to advance it to generate cam. And once it's generated, I'm going to go ahead and explore cam in order to show you that these are the individual, or rather all the opportunities that you have here, which is going to open up. So now you have the opportunity to, let me just find which it is. Bear with me for a second. So this seems like the definitive case, which again, you have the individual, and these are the 2 degree or 2 millimeter at 10 degree kind of socket. So you can see very clearly that it only has one way of fitting, and this is the segmentation, where now I'm going to go ahead and bring the the one STL file for you to generate if you wanted to do a try-in similar to this, a monolithic. But you have the ability of doing that or doing a complete throughout design for the definitive as you see here. And you can see that the detail that's captured is truly, truly remarkable. So digital dentures is certainly here, and it's certainly something that, it's at its finest right now. And I think the materials are certainly growing rather quickly. So you're able to see all the way through exactly what the outcome could be. It's really an easy process and a truly a functional, aesthetic restoration that you can truly scale. And now with the equipment that we have and the materials that we have, and as Kris is going to show you right now with Trusana, it really is an exciting time in our industry, and certainly digital dentures is here, and it's only getting better, and it's something that to tap into in a great way. So with that said, I just want to turn it over to Kris to inform us about Trusana and the materials that used and his experience as well.
Thank you, Daniel. We appreciate you and attendees. If you have any questions at all on 3Shape denture design for Daniel, you can go to zondental@henryschein.com and send those questions in, and we'll get them over to him. Thank you so much again, and I'm going to turn. Thank you. Here's Kris.
Great. Thanks, Daniel. That was awesome. Give me a sec. All we really want to have is to be able to digitally design something because it's easier to train. It's faster for an employee to become, efficient at it and a viable part of your company. It's less dirty. There's real advantages to doing the setup and being able to kind of see through the base and make sure you're able to set teeth right over the ridge. There's just so many advantages, and really the thing that we've been wanting for years is to just have a material and an outcome that's as good, if not better, than what we're able to achieve the traditional way. And I think the software and the design is here, and it's been here for a while. And I think with the help of materials like Trusana, we're now getting to the point to where we're, as I said, as good, if not better. So let me give you a little history of Myerson. Myerson's been around for over 100 years. They're probably known most for two things. They're denture teeth. They have the Myerson Kensons, the Myerson DB Plus, and the Myerson Specials, as well as Vitalium frame metal that has been sold by Dentsupply for many, many years, but that was an original product of Myerson that was purchased by Dentsupply and sold. The cool thing about Myerson is it's been a removable only materials company for its life, for the 100 years. And that's rare to find. And I think one thing that Myerson started seeing in the industry was, labs with 3D printing are going to become their own dental tooth manufacturers. So instead of Myerson fighting against that, they decided to join that and come up with a material that can be used for denture teeth as well as the base. Here's a couple of examples of some materials beyond the teeth that you may have seen on the removable side of the industry. So Duraflex and VisiClear, as well as Zerlux Acetal, are millable materials. These, again, started out their life in the traditional analog, where you wax up your case, you would invest, you'd load it into the Flex Press, which is a machine Myerson has. It would melt the material and inject it into the mold. They then started to see, the advancements happening, and again, instead of fighting it, they joined in and put their materials into a puck so that you could digitally design and mill. We also have the EMA, which is a sleep appliance. Myerson right now is the #1 CAD/CAM material producer for metal-free partials. So, you know, Myerson definitely knows the analog side of this industry, and we still have Duraflex to be able to be used in an injection machine. But they're also not afraid of advancing and moving right along with the technology. And I think that's kind of rare on the removable side. And so I guess the big thing I'm trying to say with kind of giving you the history of the company is, you know, they're going to be a company that's going to back you if you choose to kind of go on your journey on the, you know, removable side, 3D printing or digital in general. I think you have a partner with a company like Myerson. So one of the cool things that's happening in our industry is it's becoming a leader. As you can see here in these different industries, dental is leading with 3D printing. Now, all at the same time that's cool, it's also scary. You know, we've always been, you know, materials have always been created for another industry. And then someone goes, hey, that might be a good material to make a tooth out of, or a good plastic to make a denture out of, or whatever it might be. And then those materials kind of get manipulated to be specific for our industry, but it was never really many materials created specifically for the dental industry. Well, because there's such a demand, well, that means there's a lot of money to be made in 3D printing on the dental side of the industry. And because of that, that means a lot of money is being spent on development and for materials and machinery. Now, the reason I say that's exciting and scary all at the same time is we have to kind of keep up with the technology and move along with it. And, you know, to your credit, today you're watching this webinar, and that's part of that, is researching and doing your due diligence and finding out which pieces of equipment are the smartest to spend money on and which materials are the smartest to get invested with. And hopefully through this presentation, I'll let you make a nice educated decision on that. So there's a lot of development on dental and 3D printing, and we need it. You know, in the industry, you know, all these materials are the toughest materials that go in a mouth because the mouth is a really harsh place for a material to exist in. Not only the wear and the punishment from, you know, by size, the strongest muscles in the body, but the high moisture environment, the acidity, just everything that goes on in the mouth. You have to have a material that's tough, and, you know, we need it. And so finally we have a material that's tough and good looking. You know, it's beautiful and can be 3D printed and digitally designed, and that's Trusana. So I'm going to go through a couple of slides here to kind of explain to you the, you know, the strength. Now, I've sat on webinars, I've sat in on presentations and been promised the world on materials. So I'm also going to give you my real life experience with using Trusana day to day. You know, a lot of these graphs and things are really cool, and they do give you a lot of information. Some of them are more valuable than others as far as the information they give you, but you know, they are done by scientists. You know, they make a stick of material of some sort, put it in some sort of machine that flexes it or does whatever, and they kind of record the ratings on that. Well, we know everything we do is 100% different from the previous. You know, the one denture is totally different from the next denture you do. Some dentures are going to have a little more thickness in areas where other dentures aren't, and because of that, you know, you really need to just kind of work with the material and get an idea of how strong it is, and I've done that over the last 3 years. So I'm going to give you where it's better than what we can traditionally produce. I'm going to tell you where it's maybe similar, and I'll even tell you where maybe it's not quite there with materials that we can produce the traditional way. So the first is kind of the toughness of the material. The cool thing that this tells you, right? So it's 3 times stronger when wet than PMMA. Right, now that takes a lot of different kind of strength testings to kind of say that it's stronger. But the cool thing that this really does tell you is Trusana, compared to some other materials that are out there, 3D printing, actually goes up in a lot of its strength characteristics when it gets in a high moisture environment. Other materials that are out there actually are tested in a dry environment and actually weaken when they go into a more high moisture environment. So this slide here, I think, is really important in that it's basically totally saturated. The material actually starts to excel in that environment. All right, the wear resistance. So show you another slide in a bit that'll kind of explain this, but when Jim, the owner of Myerson, came to me years ago, when the project was just starting in development of the Trusana, you know, he was telling me that, you know, they were having difficulty trying to suspend particles, nanoparticles in the material so that it would be nice and wear resistant. The particles will tend to settle. It's just a challenge. And there's things to be said out there that it's not the greatest thing to have nanoparticles in a material. The nanoparticles are basically little microscopic little beads that are very wear resistant. So as a patient would wear through the plastic, they would hit the beads and kind of stop. But they're going to dislodge, and those beads are going to be able to get into the body, and there's some thought that that's not a great thing. Just in my common sense mind, I feel like that's not a great thing. So I told Jim, I was like, hey, tell me about how strong this material is. Have you tested it just in its regular state and to see how wear resistant is? Because I was thinking at that time in my mind, I was like, yeah, if you already have a denture designed, why wouldn't you, you know, make 3 of them? And if the wear rate is close to a cheap denture tooth, but you can make 3 dentures, well, you'll have 3 times the wear or life of your dentures compared to a kind of an economy produced denture. That was kind of my thought process. Well, Jim took that and actually tested the material in its virgin kind of chemistry, and the wear was 2 times that of a premium tooth. That's not 2% better. That's 2 times the wear resistance of a high end denture tooth. And so that was really great. You can see this was done by university, that we had no relation, like it wasn't something that we paid, you know, someone to do or whatever. You know, it's independent of us. And here's the graph I was talking about, and you'll see your economy tooth, high-end tooth, regular acrylic, actually Emax. This company or facility had tested Emax, and Trusana actually were greater than Emax. Now, that's apple and oranges, right? Emax is a hard lithium disilicate glass, whereas Trusana is a plastic. Now, the thing you got to understand with wear is something doesn't have to be harder than something else in order to be wear resistant or resist wear. It just has to not allow that thing that's trying to wear upon it to gain friction. If it can't gain friction, then it can't kind of grab hold of that surface and wear. So, you know, if you took Emax and put it next to some ceramic that was rough, had been ground on and never really polished, I think the Emax is going to hold up better than Trusana against something that's a normal tooth and smooth, right? So, but what this definitely is going to tell you is, compared to what we would traditionally put in the mouth, a plastic that's made for dentures or partials, Trusana is by far outperforms them. And that's real exciting. So you have flexural strength, you have flexural modulus, right? So essentially, kind of what you have with those is how far will something bend before it breaks, and how much something will resist bending, all right? And Trusana for the denture teeth has a really nice combo for being tooth material, right? We want the tooth material to be hard, like enamel, and strong that way. And so the flexural strength and flexural modulus is really, really nice for the denture teeth, right? So the denture teeth, you're not going to make an arch and think you could just flex them, right? It's going to break because it's meant to be hard, like a plastic tooth would be. If you took a card of denture teeth and they were all attached, you know, they'd be nice and hard and wear resistant, but you could like snap it because of the connector is a thin few millimeter thick connection, right? The denture base that we'll talk about is the same chemistry as the teeth, so a lot of this stuff still applies, but it's been formulated to be more impact resistant, right? So that you drop it and it's going to bounce and move. So the Trusana has a really nice balance for the tooth material between those two. This is one that's really, really nice, right? Is the almost zero moisture absorption, right? So over a 24-hour period, it's 0.3%. To give you an idea, denture tooth is 0.4%. Now, I don't know about you guys, but my experience with a denture that's been in the mouth for a while and comes in for a repair or a reline or something, and it looks, you know, like the patient may have been a smoker, or wine drinker, coffee drinker, or whatever it might be. You go to polish it and it has stains that you can get the teeth cleaned pretty quickly with the pumice, right? Nothing really seemed to get inside. They clean up well. The denture base is a different story. A lot of times it can be really challenging to get that denture base clean. A lot of times you'll see calculus adhering to the denture base, not really to the teeth, but you'll see it collecting in little sockets and pockets on the denture base. And that's because a denture base, to be impact resistant, they make porous. You know, that's why a patient has to keep it in a cup of water. It's because it can deform as it dries because it has that. Well, with that microscopic porosity comes stains, bacteria, smells, molds can be a problem, things like that. Well, not only do the teeth only absorb 0.3, but our denture base only absorbs 0.3. Some current materials that are out there for 3D printing absorb as much as 2%, right? And that can be a big problem. You know, you may get, you know, really cool kind of flexibility. You know, there's a lot of people showing like lowers in a vise and they crank it down and get a lot of kind of flexibility from it. The way they get that flexibility is by creating gaps and spaces between the molecules so that those are like bubbles that flex. And that the problem with that is some of those systems need like sealers painted on. You can't really clean some material in any kind of dirty alcohol because it'll basically absorb the dirty alcohol, and you know that dirty alcohol may have some model resin in it or whatever it might be, and it'll be hard to get it out of those pores. Problem with that is as soon as a doctor grinds on it and exposes that sealer, you know, just you know the alcohol inside, you have to make sure it dries. With Trusana, you can wash it in a dirty bath because nothing can get inside of it for the most part. So that is a huge advantage, even beyond, you know, as good if not better, or way better in not having an absorption of materials. The material tooth resin comes in a bleaching shade, comes in B1, B2, A1, A2, and A3. The denture base comes in a original pink, a light pink, a light like a reddish pink, and then a Meharry shade. So there's a lot of nice choices for a denture base color, which a lot of companies don't have. And we have some of the most popular tooth resins, two shades for tooth resins. So let's get into you know, how to kind of produce these now that you have a baseline of, you know, that it's a good material, that it's got good characteristics. Daniel went through the fact that you can design these really nice and easily. I'm not really going to get into nesting. You know, right now we're validated with the Asiga, the Maxim Pro, we have a couple of videos on Zon's YouTube channel that go into nesting. They're quick little videos. I would check those out. It's really not that difficult. If you've never nested something in any kind of software, you'll find it really easy. If you have nested something in a software, it's a breeze. It's really no different. And so you will have nested and printed your teeth. You will have nested and printed a base. And now you just got to kind of bring them together with the bonding agent. Of course, if you have a large build plate, you can fit more dentures. You'd want to be setting it about 20 degrees. You can set them a little higher, a little lower. I mean, it's hard to really say what 20 degrees is on something that doesn't really have a kind of a flat plane. Is it to the facial flange around the denture? Is it to the occlusal of the sockets? But we found that you can kind of fluctuate that degree, and you maybe slightly take away some of the mechanical properties of it, but it's a very small amount. So you don't have to be, so worried about that. And, this is a Sprint Ray printer. We're working on validation for many different printers. It only makes sense because we want to make sure that anyone who has a printer existing and they would like to use the material, but it is a painstaking process, and just be patient with us. Right now, we're validated through the Asiga Max and Pro. So once you have printed your teeth, printed your base, got them cleaned, which we recommend in 99% pure isopropyl alcohol, you're going to clean it in a dirty bath for about 2 minutes. All right, that bath should have some sort of an agitation, whether it's a spinner or just a rocking, even an ultrasonic, as long as it doesn't really get hot and it's not too aggressive, you can use. And ultrasonic's a little iffy with the IPA because it will allow for that to kind of agitate and evaporate really easy, so you'd want to make sure you have it covered. Either way, you want to do a 2-minute wash in a dirty bath. Once it comes out, I like to make sure you're using gloves when you touch any of the resins or any of the tools that have to do with resins. I'll blow it with compressed air real lightly. And essentially what you'll see is the alcohol evaporate almost immediately. And then the surface will go from a shiny to a dull. If you then see any wetting, like as you blow, you see like a wetting of the surface, that's probably still some leftover residual resin that didn't get cleaned in the dirty bath. If it's just a little bit, no big deal, move it over to the clean bath and let it go for about a minute, maybe even 30 seconds. You want it to spend as little time in alcohol as possible because it is a caustic material. It's really, the reason it cleans that resin off so nice and quickly is it's a pretty harsh material. And the Trusana, any material that you've printed, is only about 80% cured at this point. Comes off the build plate, only about 80% cured. And so it's not near as resistant to those materials at that point compared to how it would be once it's totally cured. So I like to do 2 minutes in the dirty, blow it dry, make sure there's no huge volume of residual resin. Then I will go and put it in the clean for, usually I'll do about 30 seconds. I'll pull it out, I'll then blow it again. If I don't see any wicking of material, looks like it's totally clean, I then am done. I'll usually, to be honest, I'm telling you that your final bath should be a clean bath. I'm worried some labs it won't be clean. And so, we're all labs, we're all busy. We all have technicians that we can't oversee 100% of the time. I would just put into the process protocol that you would have a little squeeze bottle. And once things are cleaned in what supposedly is going to be a nice clean bath, I would then give it a squirt rinse with just 100% clean alcohol out of a squirt bottle. I think that's a good policy to put into place. If you have any small areas like screw access holes or anything like that, I mean, it's a good point to kind of mention that Trusana was actually developed initially as an all-on-X appliance application. So a full screw retained all on however many implant appliance was why it was developed. And then once it kind of was proven to be strong enough to last in that environment, you know, as far as something that's directly screwed into the jaw with no give at all, and they found that it was very pretty, aesthetically pleasing, and held up in that environment. They said, wow, it's probably going to make a really nice denture tooth. And it did. And so if you do have it, if you are using it for an all-in-X application, and again, on Zon's YouTube channel, there's a few videos that we've done that relate to that side of things. As far as, you know, it's not too different than what you see here though. But I would squirt up into the screw holes, make sure those are really, really clean, and because they can really collect resin and be difficult to clean. So just make sure everything's really nice and clean. And then you're going to let them sit for, you know, 15-20 minutes, make sure that all alcohol is off of the surface. And then you're going to take Trusana's bonding agent. It's really nice. It comes in this little applicator. And at first I thought, you know, don't really think too much about it. But because you can squeeze and just place the resin, all the other companies that I worked with previous to that are just have a little jar, and you take a brush and you dip it in there. The whole time that jar is open and the lights from your lab are shining into that jar, it could be kind of activating that material. Also, dust and particles can, you know, find its way into that jar while it's sitting there open. You know, also the dripping, you know, you get it on your brush and you bring it over and it drips. It just, this little applicator really, you know, as a nerdy technician, I really liked that advancement. So you'll just inject it into the sockets, putting a liberal amount. You want to, when you place the teeth, you want to make sure that it oozes out a little bit. You'll then, I like to paint the bottom of the teeth as well with a little coating of the resin. And then I place the teeth into the sockets and push them in place. And you should get a little ooze of material. You'll go in there with a brush and kind of remove that. You know, this material is essentially the Trusana with a little different formulation to be a bonding agent, but you can kind of wipe it down onto the you know, the base, and it's just going to, when you go to cure it, it's just going to become part of that base because material is only about 80% cured. It's literally going to become one with it, and that's why the teeth are going to bond so nicely, is because it, you know, both materials, you know, are only 80% cured. You put this bonding agent and man, it just becomes one thing. So you could take the brush, if it's a large volume, you know, you kind of have a paper towel, wipe your brush off, kind of go along there, but if it's a little bit, you can just kind of spread it out, if you will. You want to hold it in place really nice and tightly, make sure it's secure, and then tack it with a tabletop light. There's a lot of tabletop lights out there available. You want it to be in the 405 wavelength range, and a lot of them can be adjustable. You know, keep in mind the Asiga prints at 385 wavelength. The 405 or the 385 will cure our resins, but you don't want to discolor things. Some of these curing lights can be real powerful, and if you overexpose the material, it can kind of darken it, almost like it burns it, but it doesn't. It just kind of darkens it. You only need to expose it for just a few seconds. And you want to go around to maybe 5 different places, 6 different places, and just hit it 1,001, 1,002, you know, just count in your head and go around. And all you want to do is just make sure it's going to stay in place once you kind of leave your pressure off of with your thumb or fingers. Then we'll go into your Asiga flash. This is a really nice thing. There's several companies out there that have to have a special curing unit. It needs all kinds of heat, and the process takes sometimes an hour to cure. With the Trusana, it goes in the Asiga flash that came with your machine. That Asiga flash looks like a very inexpensive, simple light cure unit, and that's exactly what it is. But the Trusana doesn't need anything extravagant, and it's nice that that unit works perfectly fine. And so you'll place it in there. You'll set a timer for 12 minutes. The Asiga flash doesn't, it has kind of just it runs for 30 minutes. So you'll have to set your own timer. Once 12 minutes is up, you'll take it and you'll flip it over and put it back in for another 12 minutes. Once that's done, you're going to take it out and you're going to place it into a water bath. This water bath is at 80 degrees Celsius, which is like 172 degrees Fahrenheit. This is an annealing process. This is a process that's going to account for 10 to 15% of the strength that I showed you in all those little graphs. So it's a very important. There's a lot of little little cheap, little water bath things on even Amazon that you can buy that will hold a temperature really nice. You know, fluctuation a few degrees up and down isn't going to cause a problem, but any more than that, I would, if you have some piece of equipment that holds the temperature, that's fine, but just make sure it's fairly accurate. Put the appliance, your denture, in a bag, just a Ziploc baggie, as long as it seals. Put in there with it like some piece of metal that has some weight to it, so that it pulls that bag down into the water, and leave it in there for 10 minutes. Once the 10 minutes is up, you remove it, and from there you would go through your normal process. I like to you know, sometimes I'll take a separating disc and separate between the teeth a little bit. You know, whatever your process would be for the final look, you may be in a good spot coming right out to just go take it straight to polish. Polishing is a breeze. Polishing this material with pumice. I like to use a rag wheel. If you have pretty aggressive contours like we had with our design, you know, if you like a smooth surface, rag will be fine. If you want a little bit more stippling, I like to use a brush with the pumice. There's also we have polishing brushes from Myerson that we use on our Duraflex, Duracetyl and the Zerlux acetyl, and those actually work pretty well on it. But really, the fastest, most efficient way to polish it seems to be with just pumice and polish. It works really, really nice, and you get a really beautiful look to it. And then keep in mind, you don't, you know, if you're thinking about purchasing a printer and maybe software and all these different things, you're not limited to just dentures. This is a milled Duraflex base, flexible partial, and these are the Trusana printed teeth. So, you know, you'll be able to keep that printer busy if you're considering the purchase. If you wanted to see videos on like design and bonding the teeth onto this material, there is on Zon's YouTube channel, there is a 2-part webinar series we did on that. It was towards the end of last year into this year, and that they're in chronological order. So if you scroll back to I think it was around this time last year, around November, we did the first one, and then the second one I think was in January, but you'll be able to find them. So one of the cool things about the Trusana base is the ISO standards for what is considered a high impact base material. Trusana was 10 times that. Now, that's impressive. My experience is with polishing this material and the rag wheel, you know, catching the denture and slamming it into the back of the polishing unit, or me hitting it with a lathe and throwing it across the lab because it catches, or you know, just simply dropping it, things like that, that it feels like very much like a high impact, a high-end denture base that you would traditionally pack or inject. I felt in my experience the same resilience as those. So that's kind of my experience, right? I'm not in a you know, facility testing this material. However they test it, I don't know. But my real life experience is I have a great deal of confidence that in day-to-day life that the denture base is more than adequate, and compared to the traditional materials is almost 100% dense and resistant to those staining and absorption of moistures. So look to the future. You know, a lot of people are kind of predicting that 60% of what we make in a dental lab by 2025 will be 3D printed and digitally designed. I mean, I could really see that number being much higher. The rate that the machines and materials are advancing I could really see that percentage jumping, but I don't think that's unrealistic for sure in any way. Other people really worry about dentists doing their own dentures with a 3D printer in their office. I'm sure a lot of people watching this webinar are 3D printing now, maybe just models or whatever it is. Like, it is not easy to keep clean. It's sticky, keeping all the tools clean, right? There's not many doctors that are going to want to have that in their dental office. If they get into any kind of production with night guards or anything like that, it's going to be a mess for them. I think it'll be very much like E4D or CEREC crowns. I think, some doctors really have a mind for the mechanical and the enjoy doing it and will do it, but I think the majority won't. And I think our relationship doctor to lab will stay very similar. It'll just be for laboratories, the ease of digital design, and really it's the ease of training by digital is the big advantage. I mean, my dad started the lab back in the 60s. I've been working in the lab since I was 14. And, that's always been the struggle is, finding qualified people or investing years into someone so that they could actually become kind of functional in the lab. Now it's a few months before someone can become functional in the lab if they start from scratch, and that's the big advantage. So I'm going to end with a little bit of a peek. So as I talked about, materials and machinery are advancing, and machines and materials are being made specifically for our industry. And Myerson right now is working on a piece of machinery that'll work with their Trusana. Trusana will work in all the traditional 3D printers that you have eventually. Right now it's validated through the ASIGA. So kind of don't worry about that, but there's some different technology for 3D printing that Myerson's looking to tap into. And so they're going to have their TrueJet machine. And so essentially this is a lot like the printer that's in your office that you print your statements and invoices with, except for it'll print 3D. It'll build a print in color. So the idea of this is, one, the micron accuracy is greater than you can achieve with a lot of the traditional, I guess you would call it traditional 3D printing machines, DLP and just that kind of bill plate layer type technology. So it'll be a more accurate build, as well as it can build in color. So you can have multiple colors in the machine. That could be denture base and teeth, and it will print the denture base, it'll print the teeth, all one unit, and with no supports. The support materials you'll see in a second is a kind of a waxy residue that the denture is built inside. And so right now the machine will hold probably three dentures on a build plate, depending on the size of them, maybe more, maybe less if they're big or small. And those dentures, one of them could be A1 and the other one could be, A3, and then you could have a bleaching shade denture, and it would print all three on that build plate: denture base, teeth, and everything. Here's a little time lapse of how it's done. So that's the support material. You can start to see the denture coming in on the inside. You'll start to see the teeth kind of in a second building. And that's inside this goop, which is like a wax. And that waxy goop is kind of boiled away. And then you're left with the denture. That denture will need, because it doesn't have any supports, will need very little adjustment and will be able to be polished up. You'll be able to do 24 arches in a day. That's kind of pushing it, right? That sounds really good, but it'll print 3 arches in about an hour is what we're looking at, maybe a little bit over an hour depending. Really packing them in on a day, you could possibly get 24. Either way, it's going to be cranking out the dentures. For most labs, 18 to 20 would be plenty. So it's really cool technology. I don't know that it'll be for every lab. I think definitely it's a cool thing to see. And again, another piece of machinery. This printer there's printers out there that use this technology, but they're used in other industries as well, and they kind of adapt it to dental. And the problem is if you just had one denture to print in a day, a lot of other machines could take, you know, many hours, some 10, some 20 hours to print that denture because it's made to do bulk. And when you only have one, whereas with this, if you just have one denture in that day, it'd be done in an hour or so, and yeah, you'd be ready to roll. So I think it's more geared towards our industry. Here's some of the gentlemen working on the project. Cool thing is, you know, they're actually worked for Xerox combined for, they have about 160 years of experience, because that's exactly what we're doing, is using that same technology to create a printer for our industry. Here's what it looks like. And so, you know, less hands, you don't have to bond teeth together, you know, that is all taken away. Of course, it's going to be faster to train someone, just kind of manage the machine, and you won't have to have somebody, you know, to the end manufacturing of that process won't take much skill. The beginning part, you know, Daniel always says that the software is it's kind of a dumb software. It takes our brain to kind of make it actually work, and I agree with that. And so it still takes you know, high-end caliber technical skills to create the denture, but on the back end to produce it will take less skill. Of course, it'll be more efficient, and because of being designed specifically for our industry, it'll be very efficient compared to some others. And again, you'll be able to do even multiple base shades and multiple tooth shades, depending on what you choose, and you'll be able to flush some shades out and replace it with different shades. So you'll be limited on the amount of shades, probably around 4 to 5 different shades, base and tooth shades, but you can swap those out. So if you had A1, A2, and A3 in there, but you need a bleaching shade, you can take the one bottle out, flush the line, replace it with the bleaching, and continue on from there. And it's not that big of a deal. And again, you have something that's all one piece, monolithic, but with color, you know, in color. So this isn't a surface color. This is, the base is billed in pink. When a tooth becomes part of the build as it goes up, that becomes tooth resin. All right, great. Well, that is the presentation. I really hope this was a complete package to kind of show you from kind of start to finish how a denture can be completed. And if you already know how that works, hopefully you got some tips from Daniel, and you got a good idea of what Trusana is all about.
Thank you so much, Kris. We really appreciate both you and Daniel and this presentation. To all of our attendees, again, if you have any questions for either Daniel or Kris, you can go to zondental@henryschein.com. Thank you for joining us here at Zon Academy, and I wish all of you a great day. Thank you.
Thank you.